mentioned yesterday we mentioned that none of these functions has inverse, right? None of these functions has inverse, right? None of these functions has is 1-to-1, and thus none of them has an inverse. So where does the inverse come from? Right? And we talk about it that we created new functions. So let's see how the new function was created, right? Yesterday we talked about it that if this were sine curve, right? If this were sine curve, right? So let's mark a couple points, right? We can pick and choose different pieces. As if that piece is increasing or decreasing, as long as the piece we chose is 1-to-1, we can use that piece to create an inverse. Okay, among all the choices, okay, among all the choices, which piece did we pick? We pick the piece from this point to the next point. And what are they? What are these points? What are these points? Right? Well, then we have to know the curve pretty well. We have to know how the curve is being created. So before we identify these points, right? We can identify this piece, that piece. Let's identify the points on the sine curve. Okay, the sine curve, as we know of, the domain is all real numbers. Okay, the domain is all real numbers and the range is between -1 and +1. In other words, the curve bounces between -1 and +1 vertically. Okay, so that's a vertical concept and this is a horizontal concept. Okay, so before we do that, I want you guys to mark a few points with me. Okay, on the sine curve. Okay. This point. Okay, and also reflect on what I want you guys to reflect on. Reflect on the nature of this function, sine. It takes input, okay, angle. So I'm going to use A. Okay, let's use A. A is angle. Okay, so the angle is the input for sine. And then produces output. The output, of course, is sine of A, which is, as being defined in the definition. So angle is the input. The output is what? The output is a kind of ratio. Okay, so before we create, right? Before we create, we decide which piece is going to be the piece we choose. This process has determined the result is going to be a completely new function. And what is that new function we talked about yesterday, right? It's going to be the angle is between -π/2 to +π/2. So let's mark a few points to see what we are doing here. Okay, what we are doing here. All right. We should be able to mark that point, right? What would that be? The angle is 0 and the ratio is also 0. Right? And this piece, how about this point? How about that point? Could you guys mark these 3 points for me? Now you can also reference with the unit circle. So what are these other 2 hearts? What are they?
Would that would be pi?
That's right, pi. The output?
0.
Ratio is 0. Very good. How about this other point?
Negative pi 0.
Negative pi 0. Right? These are the x-intercepts we talk about, right? These are the x-intercepts we talk about. So how about these lowest point and the highest point? I know these points are not precise, right? These points are not precise. If you look at the curve, it's hard to identify what is it. But if you reference the unit circle, right? Look at that unit circle, that blue number. One is the largest blue number, one is the smallest blue number. And then you're going to go find it, right? So this point, the highest point is what? Is pi over 2. That's the angle. And the output is 1. And this other point is what? Negative pi over 2. The output is negative 1. So angle ratio, angle ratio, angle ratio, angle ratio, angle ratio. And there are lots of points in between. Pi over 6, pi over 4, pi over 3, 2 pi over, there are lots of points. But because we done the truncation, so this process we do is called a truncation, okay, truncation. So I'm going to write down that word. Truncated. Truncation. Chopped off. Chopped off. What did we do to chop it off? What's been chopped off? From this piece, from pi over 2, from this point, pi over 2, 1, input pi over 2, output 1, which is a ratio. From this point, pi over 2, everything over pi over 2 is being chopped off. And what the consequence of this chopping off, right? Graphically. Well, graphically, it's very easy to do. But we have to look at the algebraic interpretation. The algebraic interpretation saying that the angle for the newly created function will no longer, the domain will no longer go beyond pi over 2. And the other direction, the truncation takes place. We're going to truncate all of these. So all of these will not be the consideration of the new function. So this function, even though it is called sine, it is a new function. And what's the consequence of this truncation? This piece, okay, this piece. This piece is still between -1 and 1, right? Range-wise, but domain has been severely truncated. Therefore, we say these two functions, okay? These two functions, that function and that function, they are completely different function. They are completely different functions. Okay? Although they have the same range, they have different domain. They have different domain. All right? Now, on the graph, it's pretty easy to truncate, right? It's pretty easy to truncate. But as a result, we get this. Now, the question is that you say, well, in the future, when you mention sine, or the restricted sign, sometimes we call this a restricted sign or constrained sign, which one do you refer to? Which one do you refer to? For example, you're going to see sine function being mentioned over and over again in the literatures. Which one do we refer to? We always refer to the first one, unless otherwise specified. Unless otherwise specified. Do we often hear these, phrases in our reading? So in the future, whenever you see sign without specified otherwise, without specifying the domain as such and such, it's always referring to the sign that we know so far. So then you say, how about this function then? This function actually is rarely mentioned, is rarely used, except, okay, in the following situation, Okay, so I'm gonna come back to address this, after we're done with this inverse function. So now with this piece being, with all of these truncation done, the consequence is this piece of curve. And what's the domain? What's the range? So let's mark the points. This point and that point. What are they? This point is the same as this guy. Same. And this point is the same as that guy. And 0, 0, the same. Do you guys see the difference? It's like we cut from this point. Everything is being cut from these two places. And we have this little piece left, and that's this piece. And this piece of function is increasing, it's 1-to-1, it has inverse. So the inverse function, the arcsine, is the inverse to this function over here. Okay, this function over here. So I'm waiting for you guys to write it down because I'm going to clean this up and then we're going to proceed. Okay, and what's the consequence of this cutting? Right? What's the consequence of this cutting? Okay, let me see if I can bring another picture into the in our situation. What's the consequence? Right? What's the consequence of these processes as being reflected on the unit circle? As being reflected on the unit circle. Okay, I know this is a holy mess. Okay, so what I'm going to do, I'm going to have to do this all over again, but that's fine. Okay, so what I would do is I'm going to, some of the pieces will be done all over again, right? So we're going to do the truncation. Truncated, you guys know that, right? And these four, there's a correspondence. So all of these are truncated, right? These pieces are chopped off. And this is the piece we left. As the consequence of this chopping, as a consequence of this chopping, if you look at this piece of curve, right? The newly created function, the domain is from -pi/2 to pi/2. The domain is from -pi/2 to pi/2. What does that mean on the unit circle here? Right? What does it mean from the unit circle here? What does it mean from unit circle here? The angle can either be measured still from the same position. You can either measure this way. You cannot go over there. You can only measure as far as here, counterclockwise, or measure to this place. You cannot go over -pi/2. So the other pieces, right? So you can only measure. So for this new function, here, you can only measure from the standard position, still from the standard position. Either from here, you hit the wall, and over here. What does that tell us? quadrant 2 and quadrant 3 are out of the picture. You follow me? Quadrant 2 and quadrant 3 are gone. Do you guys follow me? That's the consequence of this truncation as well. Now, can we, before when we measure angles, right? When we measure angles, we can go around and round, right? We can go around and round, right? Can we do that anymore? No. Because if you go around, you're going to go beyond the pi over 2. If you measure clockwise, if you go around, you're gonna be beyond. You're gonna get over negative pi over 2. So you cannot go around and round. So you can only measure either this way or that way. You guys follow me? So this truncation on this graph, right, cause a tsunami of effect. So we no longer get to use quadrant 2 and quadrant 3 for this newly created function. So that's how the restriction, okay, that's the significance of this restriction. It's a big one. It's a big one. Now, we still haven't created our function yet, right? We haven't created our function. So with that said and done, let's move on to the next piece. Okay, let's look at the next piece. Okay, we're gonna review. Okay, hold on. Come down. Okay, with this function, right, with this new function here, right, we have created this new function. Wait, we have created this new function and we know these 2 points. Okay, you guys must know these 2 points. What are they? Can you mark them again for me? Can you mark these 2 points for me? Can you mark these 2 points for us? These 2 points. Domain range specified this new function. Okay, we're going to call it G. Okay, sine of x. Sine x. If I put an a here, that's going to be a. So it doesn't matter. This function, under the circumstances, okay, with restriction on negative pi over 2 to pi over 2, right? We know its implication. This function is a one-to-one function. It then has a unique inverse. It has a unique inverse. And that inverse, we're going to have a name. G inverse of x. Before that function is even created, okay, recall what we did with inverse functions, right, before. this new creation is going to be consistent with what we have learned before. Number one, if this G's domain is from negative pi over 2 to pi over 2, it's inverse, right? It's inverse. What will happen to the inverse? The inverse function's domain and range is already set before we even give it a name. Okay, so what is the domain and range for this guy? If this guy's domain and range is given as such, right? Wait, this guy. What's the domain for this function here? I'm sorry, here, I meant here. What's the domain here? The domain is right here. And what's the range? What's the range? The range will be that, right? Or if you like that interval notation between -1 and 1. So after this new function we created, we haven't even given a name. I know you know the name. Okay, pretend we don't even know the name. What will be the domain of this new function, this inverse function? Its domain is going to be the range of the other, which is this guy, ratio, right? The function sign of A with the new domain and range, the input is an angle. The angle into G and it comes out sine of A, that's the ratio. The new function, what will happen? The new function will take ratio, okay? Because we understand that the inverse function is a swap of input and output, right? So this new input is going to be what? Is going to be ratio. Ratio. And this ratio has to be between -1 to +1. Okay, so this ratio has to be between +1 and -1. So that ratio has to be between -1 and +1. What output would that produce? We don't even have a name for it. What will be the output? The output will be angle. That's the fundamental relationship, which is consistent with what we learned before. So the domain and range is simply a swap. So now you should understand why I spent all that time on this before. Those things we did before is foretelling what we're doing here. Okay, about exponential, logarithm, all that inverse finding process we have emphasized over and over again is going to be reappear in here in different, it's just because in the past it's just numbers, right? They're always input is numbers, output is numbers. But in this case is ratio, angle. You guys follow me? So now it's about time we give the name to this inverse function. There are two names given to it. Okay, one is called Arcsine. Okay, and the alternative name, okay, the alternative name is sine inverse. The Arcsine for name actually was popular before, but the sine inverse, this name is a little bit confusing. That's why we need all of these explanations. Okay, this sine inverse is not the sign we have learned before. It's not the sign you use all the time and by default is that sign. This indicates the inverse to this guy. Do you guys follow me? Do you guys follow me? So that's the part that's most confusing for a lot of people. Because when people see that by intuitively, they will think, oh, this is the inverse to the sign from which is domain from negative infinity to positive infinity. The answer is no. This is referring to the inverse to this guy. But because this guy is rarely mentioned, it's rarely used, and that's where that causes the confusion. Okay, so I'm going to try to use these two names interchangeably because most of the time in the literatures these days, sign inverse is often used. This notation is often used. Okay. And this one, I'm also going to use it because you also see it too. You see that too. So I'm going to put both of these because they're considered the same function with the same domain and range. So let's see, what will be the range for the inverse function created right now? Of course, it's going to be this guy. Do you see that the consistency is being honored? Do you see that in that process? A new function with a specified domain and range. And this function has inverse, which is this guy. Okay. And it's inverse, right? So the new function's input is angle, output is ratio. Its inverse input is ratio, output is an angle. And where does that angle belong? That angle has to be between negative pi over 2 to positive pi over 2. Okay, so let's see how that new function is created and how the curve is being created. And also we're going to get to write down the functions using the correct notation. So everybody, please get your paper, pencil. Get your paper, pencil. Okay. Get your paper, pencil. So this is the sign. This is the you know, this guy, right? The G. This is the G. When I refer to the G, you know the domain is being constrained, restricted. Okay, however you call it. And the range, and what is more, there's a bunch of other properties we're gonna discuss. Okay, among them, we know that G, which is we spend so much time, right? G, the composition of functions, right? Remember this property? Yes? Except at that time we use F, right? Remember this property? Do you guys remember this property? This property will also be true for this pair. Do you follow me? Okay, so we're going to discuss that later. Okay, so this is G. That's G. That's G. Okay, so now this is the general tone. This is the general tone. Let's see how we're going to work it to create the new picture. The new picture. On this picture of G, what is the meaning of each point? The meaning of each point on that curve is going to be the first input is angle and the ratio of that angle. How about the picture we are about to create? is going to be reversed, right? Swapped. Remember when we try to find inverse function, what do? We have xy, we swap xy, right? When we swap that xy, what happens? Domain and range swapped. Domain and range swapped, right? So that's the swap we're going to see. That's a swap we're going to see. So I'm going to set up the rectangular system. And you know what I'm going to do? Because I have pre-prepared some of these things. Okay. I'm just going to put it that way. I'm going to remove this picture. Oh, it doesn't allow me. Oh, that's okay. Okay, hold on. I'm going to do this. Okay. All right. So a blank space, empty space. Okay. So this is the G. And we're about to create a G inverse. Okay, so this is a G. Okay, so how about you guys write it down? Am I going too slow? I think I am. I hope I don't lose your attention. Yeah?
I think it's better if you go a little bit slower for this one. Okay.
But you need to make sure you hold your attention, okay? Because it's intentional to go slow, but I also run the risk that you might just lost interest or lost your attention, which is also understandable, right? So this is the G, and we're about to create a G inverse. Okay, so about to create a G inverse from the graph. And meanwhile, we're going to work on the notation. Okay, we're going to work on the notation. How to write it down properly. I see all kinds of mistakes writing things down, which demonstrate that the limited understanding about these two functions. So for that reason, I'm going to do these points with you. So for example, on this curve, right? On this curve, we're going to mark some points. We're familiar with this piece, right? We're going to mark some points. So to mark those points, I'm going to create this table. 3 columns. The input A, sine of A, and the pair, angle, sine of A. Okay, so the point I'm going to give you would be, okay, so please work with me, okay, pi over 6, pi over 4, pi over 3, okay, that's the counterclockwise, pi over 2. In the other direction, okay, it's going to be all of these negative. Okay, so you're going to get those numbers for me and make those points. Okay, so I'm going to take an example. Sine of pi over 4 is √2 over 2. of 1 over root 2, the blue numbers, right? The blue numbers. So this point is going to be pi over 4, comma, 1 over root 2. On the other side, of this other table, okay? This time the input is going to be ratio, sine inverse of x, or arcsine, x equals 2. And the next one, we're going to have the input output. The input is ratio. And the output is angle. Okay, so before you guys do this, I'm going to show you a couple examples. This table is for the new picture we are about to create. Okay, I know you guys get it at your fingertips, but don't do that. Don't do that yet. Well, you can do it. I'm not going to tell you not to do it, but we just want to make sure we know how this new picture is being created. Okay. So this is the angle, and that's the ratio. The output, ratio, angle. Do you guys see that difference? Swapped. This is the effect of swapping x, y. Now, the ratio, however, right, the blue numbers, what are the blue numbers? The blue numbers can only be what? Between -1 to +1. Look at that blue number, right? So the input for the arcsine can only be those blue numbers. Do you follow me? So what are those blue numbers? Can be half, can be root 2 over 2. Okay, so let me put it here. The blue number. And these are the blue numbers where? On the first quadrant and the second and the fourth quadrant. Remember, we talked about that these two quadrants, we don't look at them, right? They're out. They're out. You follow me? They're gone. Okay, chopped off. We only have quadrant 1 and quadrant 4. With that said and done, okay, let's do the creation. So I'm going to give you these numbers, okay? And you need to work with me and write down the notation, okay? And the next one would be root 3 over 2. And this is going to be 1. Negative. -1. Is everybody ready? Right? So we just did pi over 4 as the input for the g function. Its output is a ratio. Now the output ratio, the input will be what? Angle. So how do we write it? You write it, oops. 1 over root 2. Okay, so when you write it, this is how you write it. You write it arcsine 1 over root 2. Okay, put it on your paper. Or sine inverse 1 over root 2. is equals to pi over 4. Do you guys follow me? Do you guys follow me? On this side, you write this way, sine of pi over 4 is equals to that. So these are the two tables laid side by side as a one-to-one function. One is the g, the other one is the g inverse. You follow me? Yes?
Professor, question.
Yes.
For Arcsine table, is the x supposed to be a, or you want to keep x?
I want to keep it x.
X, okay.
Yeah. But that x is a ratio.
Thank you.
Mhm. So I'm going to put, I try to put as much information as possible on one table, okay? And this piece belongs to that interval. There's a restriction, right? There's a restriction. You guys just have to follow, right? Sometimes it's impossible to put all the information there. It's just too much, right? It cannot be held on one screen. Like in this case, right? Now it's a little bit too crowded. But do you see this little negative sign there? -1 here? That's what I'm a little afraid of. So let's see if I can make it 65%. See if I do that, the table gets, oh, okay. So this time it works. It works. It barely squeezes in on one picture. Do you guys see that picture? For this point, right? It's 1-to-1. Do you guys see 1-to-1? This will reflect on the nature of 1-to-1. Pi over 4 is the input. 1/√2 is the output. And you reverse it. I'm sorry, this is pi over 4. My bad. This is pi over 4. Okay. And input output swapped. Input output swapped. So let's look at what do we see on this point in the picture. Okay, so I'm taking pi over 4 comma 1/√2 from the G, and we're going to mark that point in this picture. Which is green dots, the green dots. Okay, what happened on the other side? The other side, I simply just swap the two numbers, swap the coordinates. Do you see that? I'm showing that swap in front of you. It's a red right there. Okay, and this point, green, is pi over 4. The output is 1/√2. And the other point, the input is a ratio. The output is pi over 4. Do you guys follow me? This is just one pair. And your job is going to do the other pair, do the rest of it. But I'm going to do one more example with you. Okay, I'm going to do one more example with you. Are you guys ready? Did you kind of get it? 1-to-1. 1-to-1, including how you write it, right? How you write it. For example, I saw people write it in hilarious, terrible way in calculus classes. Unforgivable, unforgivable. Okay, I'm going to show you what I saw from my, some of my past students. Okay, no name mentioned. No name mentioned. Did you guys write them down? I'm going to show you the mistakes I saw. The mistake I saw was often like this: sine inverse pi over 4 is equals to 1 over root 2. Typical mistake. You know that's a mistake, right? Because the formula of the inverse, it must be a ratio. It must be a ratio. This shows that this student has no idea what is the input for sine inverse. Has no idea what the input for what? For what? For the nature of the function. For the nature of the function. I want you guys to put this number. If you have a calculator, you input sine inverse of pi over 4. Tell me what you get. I assure you, you're not getting 1 over root 2. You're not getting 0.707. So what's going on there? Why you enter that, you still get a number? Yeah? What do you get? Okay, so I'm going to enter something here. Let me see if I can get something down here.
So would the correct form be sine of inverse of radical 2 over 2 would equal pi over 4, right?
That's right. Absolutely. That's why, you see, that's why I want you guys to write this as I'm doing it. You do it, don't take any shortcut. Write it along the notation and so on. Exactly the way I write it. Can you do that for me? You'll be doing yourself a great favor. When I see this kind of mistake, you get 0 for that step. 0, no partial credit at all, because it's a complete misunderstanding. I should give a negative number to it, right? No understanding of the inverse function. What should be the input? What should be the output? And also, sine inverse of pi over 4 is not going to be equals to 1 over root 2. That's another fatal mistake, right? So let's see what sine inverse pi over 4 equals to. And I'm going to give you my explanation. The calculator will give you an answer. The calculator will give you an answer. And what's the value of 1 over root 2? I was just telling it, I believe it's about 0.707, right? So why are these different numbers? Why are these different numbers? Well, when sine inverse function is called for on your calculator or whatever machine, the first thing the program is going to check is to check your input. If your input is between -1 and 1, right? The ratio has to be between -1 and 1. That's a domain for Arcsine. And pi over 4 indeed is less than 1. It's between -1 and +1. So pi over 4 is going to be treated as a ratio. For that ratio, this ratio, what is pi over 4 as a ratio? What is pi over 4 as a ratio? It's about 0.78540. So this arcsine function take that ratio as the input. It produces a radian. This 0.90334 is a radian. It's a radian. Okay, and that radian is supposedly to be between negative pi over 2 to positive pi over 2. So it's in the range. Do you guys see that? So it's absolutely different story from what you thought. That's how it's so important. That's why from the beginning of the semester, I put so much emphasis that we need to understand what is the input and what's the output. You only have to be clear about what's the input and what's the output. And what's the meaning of swap. It's all about that. It's all about that. And mathematics is always consistent, ever consistent. All right. Okay. So now you understand this is a mistake, right? This mistake is huge. If this step is 2 points, I'm going to minus 5. Why? It shows complete misunderstanding about arcsine sine inverse. Input and the property of input. And on top of that, numerically, it's incorrect. So do you agree with me that 5 points reduction is warranted? Yeah? I'm sorry. Math is just, it's either right or wrong. It's either right or wrong, right? So you can see, you can check using with your calculator. With the frequent and the free use of a calculator to make this kind of mistake is absolutely unforgivable. I should subtract 10. Do you follow me? Complete, no understanding. That's why we're doing this exercise right now. You guys follow me? So with that said and done, we have done one examples. Okay, I'm going to clean this up. Okay. So let me complete this piece. Domain pi over from negative pi over 2 to pi over 2. Okay, the input. Okay, let me say it again. This input is treated as a ratio. As a ratio and checked by the program. To see if this ratio is between, if in the what? If in the domain between -1 and +1. So that's how this program works. The sine inverse function, that program, the implementation of that program, okay, I can write a flow chart of this program for you, right? When arcsine function or sine inverse function is being called for, right? When this program is being called for, what will happen? The first thing the program does is to check the input. Check input X. Is it in the domain? If in, they will process it. If it's not, so it doesn't matter what form you give it to me. Give it to it. You can give a 4 over 5. You can give it pi over 6. They will all be treated as a ratio. If that ratio falls into that domain requirement, it will process. Okay, so there'll be two branches, right? So now I want you to, I kind of want you to believe me, right? Have your calculator next to you. So there's two branches. One branch says, yes, it's in. Yes, it's in. And the other branches say no, right? If it's outside, it's outside. If it's outside, what will happen? Give error message. I taught program before. I know how that program works. So yes, then they will give you an angle. The angle is going to be radian. Okay. So if it's yes, what will happen? It's going to give you produce angle in radian. Of course, if you want it to be degree, that radian can be converted to degree for some calculator, which is a very simple thing to do. Just multiply, a multiplier. Do you guys follow me? That's what's going on. So now I ask you guys to input, try Arcsine. I'm going to give you a value, okay? Try Arcsine 1.2. Do you have that button on your calculator? Try this. What do you get? You should get an error message. I don't even have a calculator. You see, I don't even have a calculator. I rarely use that calculator because I understand the mathematical principle and its implementation. Do you guys follow me?
Mm-hmm.
What do you get? You should get an error message, do you?
Yeah.
If you don't get an error message, you should return your calculator, ask for a refund. Yes?
I got error.
Of course, I knew it. Why do I knew it? It's not because I'm so genius. No, I'm not. Because every mathematical principle is implemented in the modern machinery. Whenever they apply, these mathematical principles will be implemented in those modern machinery programs and so on and so forth. They're completely respected. They're completely respected thoroughly. And this is to say these principles are respected all over the world, across the languages. Across the languages. Okay. All right. So with that said and done, right, the kind of mistake I saw is absolutely appalling, right? And this is the reason why, because I've seen so many of such mistakes. That's why I insist you guys doing this. Okay, so let's do one more. And then it will be your turn. Okay, then it will be your turn. And we can do the breakout rooms, right? Let's look at negative pi over 3. Sine of negative pi over 3. We can find its value pretty easily, right? You just do the ARD, right? You just do ARD. What do we get? We get negative root 3 over 2. So the point is going to be the input is an angle, the output is a ratio. So on the one hand, you need to understand the fundamentals. On the other hand, you have to be able to express it algebraically correctly. So it's a big job. It's a big job. Okay. So now swapping it, right? So when we are doing ARD, what happens? I haven't mentioned ARD earlier. When we do ARD, what do we do? ARD, right? You measure the angle, it's a clockwise angle measurement, right? Do I need to repeat that whole thing all over again? right? So when I do negative pi over 3, so let me move this down over here, closer to our table. Okay, so when we saw pi over a negative pi over 3, what do I do? Talk about ARD, right? So I'm going to measure that angle. That's a negative angle. I'm going to measure clockwise, negative pi over 3. Boom, that's here. And a point on the unit circle is the point of my choice. And we take the blue number, right? Now, so let's do ARD. What do we do when we see? What do we do when we see Arcsine? What do we do when we see Arcsine, right? Arcsine, negative root 3 over 2. What do? We do DRA. DRA. And being mindful of the what? Domain and range. Okay, so now negative root 3 over 2. Negative root 3 over 2. So you're going to look for the negative root 3 over 2. And then you say, oh, what is the terminal for that? And this is the terminal. But this is the arcsine, right? Arcsine's range. So arcsine range is not going to be going, it's not going beyond this negative pi over 2. It cannot go beyond there. You cannot turn around and round. You follow me?
Mm-hmm.
You can only hit here. You can only do one turn. Okay, so your answer, before you put down negative pi over 3, you know your answer is between negative pi over 2 to pi over 2, which means your answer is always either just in this range. You cannot go beyond. And then, of course, you measure that angle, that's negative pi over 3. Then the next question is, could I measure this way? No. You cannot even pass these 2 quadrants. Okay? You cannot. You cannot say, I'm going to turn it. I'm going to get, what would that be? 5 pi over 3. With 5 pi over 3 is negative root 3 over 2. That answer will be okay? No, that answer is completely wrong because your answer has to be between negative pi over 2 to pi over 2. Do you guys get it? You cannot even fly over it. There's something in the military, in war, it's called there's an area, no man land, right? Is that the word?
Yeah.
No man's land. That's no man's land. You cannot even fly over, you'll be shut down. Do you follow me? No man's land. When it comes to arcsine. Okay, so now let's look at the correspondence, right? Let's look at the correspondence. For each ratio we are familiar with, right? Before we shut down, for the ratio of 1 over root 2, we have another one. Right? In order to guarantee the 1-to-1ness, what do we have to do? We have to get rid of this guy. Right? Otherwise, we don't have the 1-to-1, right? Ratio to angle, right? Ratio to angle, it has to be, the output has to be unique. Do you follow me? So the answer here has to be negative pi over 3. It cannot be 5 pi over 3. Or anything that fly over that no man's land. Did I make myself clear?
Yes.
Right. Are you ready? It's your turn now. You're going to write the notation as such. You're going to write the notation as such. And then, of course, let me finish this piece, okay? The input is a ratio. The output is what? Negative pi over 3. So after I mark these 2 points, okay, after I mark these 2 points, we're going to work in our breakout rooms. That's the green. Okay, so I can make this a little bit larger. You can see, I wish I have a big blackboard, right? I missed the classroom, So let's see, where's the green? Where's my green? Where's my green? I should have another green. Ah, forgot to click the dot. Right there, right? And the other point is gonna be red. You can use whatever color you want, really. Okay, this is gonna be a red dot. Okay, so let's mark it one more time. Let's mark it one more time. So this point, this new point is negative pi over 3. The input is angle, the output is ratio, negative root 3 over 2. Okay, and this other place, swapped. Input output swapped. Negative root 3 over 2. Output is angle. Angle must be between negative pi over 2 to pi over 2. Okay, and of course this one was pi over 4. 1 over root 2. And this other one is 1 over root 2. Pi over 4. Okay. So after you write it down, we're gonna work on these in the table, on the table. We're gonna have a breakout rooms, and you can choose to go to Farouk's room or you stay here. Even if you stay here, I'm gonna let you work, you know, by yourself. And if you have any questions, and I'm still gonna cover all the points, and then we're gonna converge. Okay, we're gonna converge. Hopefully before the end of the class, we can get this done. Okay. All right. So go back to the table. Go back to the table. Okay, that's the complete show of the table, right? Sort of. Okay, ready? Ready? You voluntarily go to your, you know, go to the, go to those rooms.
Professor, I prepared my whiteboard with those examples, few of them. So I'm looking at the breakout room. I can stop by over there, see if anybody is going to join.
I also ask you guys to reflect on the definition of function, because the new G, the new G has to be, you know, agree in, you know, has to agree with the definitional function. For each input, there's a unique output. Its inverse, for each input, there's a unique output. There can only be one and only one output for the ratio between -1 to +1.
Ms. Wang, I have a quick question.
Mhm.
So when doing arcsine and sine of inverse, it doesn't really matter which one we do, they both have the same outcome, right?
What do you mean?
Say for example, if like 1/2, so like arcsine of 1/2 equal to pi over 6, right?
Right.
So it would be the same, thing if I say sine of inverse would of 1/2 would also equal pi over 6, right?
I didn't get the second part you said.
So sine of -1 of 1/2 would also equal pi over 6.
No, it equals -pi/6. You're talking about arcsine -1/2, right?
No, positive 1/2.
Positive, yeah, that's always pi/6.
So they're both the same no matter what. Okay, so
Oh, you mean the notation wise?
yeah.
Yeah, they're the same thing.
Okay, I see.
I didn't hear pi, I didn't hear -1/2, right? Yeah, the output should be one and only. And that one and only has to be between -pi/2, -pi/2 to +pi/2.
See, okay.
Okay, this is just a two alternative way to write it. As I said earlier, most of the textbooks these days, they use sine inverse. But there's still some textbook uses arcsine. But they really mean the same thing. The latter sometimes is more confusing because people would think, oh, this is the inverse to the sine. No, that sine, you know, doesn't have inverse. Okay. So that's why we create this G, right? And this G is rarely used, rarely mentioned. So that's what makes the learning difficult.
I see. Okay.
So whenever you see sine, it is still the sign as we know of. It's domain from -infinity, +infinity. You press the button for sine curve, you get that curve. Whenever you hear sine mentioned, that's the curve is referred to. That's the function referred to. This new sign, this restricted sign, is rarely used. You cannot even get the graph on the calculator. You can't, unless you have to limit the interval. You don't get that function standing alone because if there's no otherwise specified, the sign as we know it is always the sign we have always known. But the arcsine we know is the inverse to the sign, to the restricted sign that's rarely mentioned. Do you know what I mean?
Yeah. No, I see.
So whenever you see sign, you don't have to debate it. You don't have to ask your professor, is this a sign with all real numbers domain or from between -pi/2 to pi/2? You don't need to ask that question. By default, is that domain with all real numbers. But you just have to know the arcsine is not the inverse to the sign we know. It's to the other one that's behind the scene. It's hiding. It's hiding. Nobody really care about it. But we need to know about it. We need to know it's hiding in there. Okay. All right, guys. All right, guys. How are you guys doing? I have closed all the rooms. I trust you guys know what to do, right? Including writing down the notation. On the Arcsine side, you don't have to write both, but for this time, I want you guys to write both. In your actual practice, you don't need to write both. One is sufficient. I just want you guys to practice the notation, okay? You never know which form your professor prefers, okay? Sometimes you professor prefer this one, sometimes your professor prefer this one, and I cannot speak for them, for you guys. So you just have to be familiar with both forms, and you know they're the same, okay? For this time, you're gonna write both, and when you're writing it, remember the input on the G is angle, the output is ratio. The input on the Arcsine, the input is ratio, the output is what? The output is angle. And the ratio has to be between -1 and +1. The output has to be between -pi/2 to pi/2. So both conditions must be checked. Okay, so if you give it an answer outside the range, you're automatically wrong. You're automatically wrong. Okay, for example, I have students give this kind of answer. Okay, there's a sign of inverse of -√2/2. The answer they give me is -pi/4 and 7pi/4. And sometimes they give me even more answer. If this is the question and your answer is like that, if this is a 5-point question, you're going to get -5. Reason. Even though there's a correct answer in your choices, but the fact that you give 2 answers, you didn't understand what's one-to-one function. So number 1 violation, this demonstrates the student does not understand one-to-one concept. Okay, function concept. What do we mean by function concept? Function concept is for each input, there should be exactly 1 output. You give 2 outputs, right? And you don't understand one-to-one concept, you should have exactly 1 answer. So even though between the 2 answers, there's 1 correct answer, you're gonna get 0, 0, 0. I'm sorry. Are you guys with me? You put these 2 answers for your professors to choose, guess what? You get 0. You better make that decision before you turn in the answer. Okay? This is the situation, the professor has no reason to give you any point, none. Second reason. Okay? No understanding of function concept. One-to-one concept. You can see it's a repeat. It's a repeat, it's a different order. Okay? Without understanding of these basic concepts, of course, you're gonna get 0. Is that clear, everybody? Yeah?
Yes.
All right, so you can see what I've been emphasized since the beginning of semester. Function, one-to-one, right? We still are in the theme of function. That a violation of function, input, 1 input, 2 output, that's not a function. Not a one-to-one. Not to mention, this student has no understanding of trig functions and its inverse and the inverses and the trig inverses. The list can go on. This simple mistake shows so much because we are assessing you. We are assessing your understanding. Do you guys understand? Yeah?
Mhm.
All right. Without further ado, let's connect the dots today, okay? Tomorrow we'll continue this. We'll continue. Okay, there's a lot of other observations. So let me put on the Arcsine. Wait. What's going on here? I'm trying to connect the dots. Why? Arcsine X. That doesn't show me. Okay, there. Okay. And what if we put them together? So I'm going to bring these two curves together with the other one. Okay, so Arcsine X. Okay, I cannot move the dots along with them, right? You guys can make the dots. And next, they are still symmetrical with that line of symmetry, which is y equals to x. Okay, that line of symmetry. Okay, so what you need to do today, we're approaching the end of the class. Tomorrow we're going to wrap it up, right? And tonight you must do these plotting all over again, by yourself. And what you need to do is you put the red dots and green dots and mark each one of them on the picture you do. Do you follow me? Like the way we marked them. This way, I hope it will ensure when any questions of such nature is encountered by you in the future, you will not make those mistakes that I just mentioned. Okay, so I'll see you guys tomorrow. Have a great day. Quiz number 13 was out last night. And you should expect two more quizzes. Of course, one of them is going to be about the inverse function. But the next quiz probably will come out tomorrow. Okay. And the other quiz I might be giving you, I'm going to give you a review quiz on exponential and log to see that inverse function relationship again. And so you can see the consistency, the beautiful consistency that demonstrated in mathematics. Okay, and reflecting on the definition of function again, the definition of one-to-one function all over again. All right. I'll see you guys tomorrow. Have a great day.
Thank you, Professor.
Of course. Thank you, Farouz.
Professor, I have one quick question.
Sure.
It's not kind of related to math. It's related to like a little bit outside school.
I'm
But,
sorry.
like, it's not related to math or anything.
I didn't quite get what you said. I'm sorry, Jacob.
It's not related to math.
It's not related to math. Okay, so I'm going to turn off the recording.